This is Autoline This Week, the show that gets you inside the global automotive industry. Autoline This Week partnered with the Consulate General of Canada in Detroit to produce this episode.
Hi, I'm McElroy, and welcome to Autoline This Week. Today, the discussion is all about batteries for electric cars. How low can the price go? Is there going to be a material shortage? What about those battery breakthroughs we keep hearing about? Well, today we've got a special guest, Tal Sholklapper from a company called Voltaiq, who's an expert in batteries. We also have Chad Kirchner from EV Pulse, my colleague, joining us as well for this discussion. Hello, everybody, and thanks for joining us on the show.
Good morning.
Morning. Thanks for having us on, John.
Tal, I got to start out with battery prices. That's what everybody is talking about. As we all know, the cost of EV batteries are so expensive. Can you give us an idea now where the cost is and how low can it go?
Yeah, it's an interesting time. Just over the last decade, if you look, we've had a 10x reduction in battery costs. It was over $1,000 a kilowatt hour. And now it's down to, under $100 a kilowatt hour in most estimates. We're having a little bit of, temporary movement right now as supply chains rush to catch up with economies of scales as they're ramping up. But it's going to continue to go down over the next few years. Expect, get closer to that bottom line of maybe $50, $60 a kilowatt hour over the next decade or so as the supply chains catch up.
That's pretty good. I mean, even under $100 per kilowatt hour is more than even just a few years ago people were saying was possible. And now you're saying $50 to $60. That would seemingly put it on par with an internal combustion engine powertrain, wouldn't it?
Exactly. And I just remember about 10 years ago when I started Voltaiq, I was working on a Department of Energy RPE project, and the whole premise of the project is that you needed alternative chemistries in order to beat that, $200 a kilowatt hour mark for lithium-ion batteries, because they'd never get there. And just, economies of scale are very powerful. We saw this in solar and silicon. We're seeing the same thing happen in batteries right now, and it's going to be hard to beat with anything else on the market.
So you make an interesting point, which is, hey, we didn't think we could get there with lithium ion, and now we are there. You've set sort of a floor at $50 or $60. Can it go lower than that without a different chemistry, or are we going to eat crow in a few years when it's down to 20 or 30? Like, what's the either what's the prediction for what's next beyond that? Is that like a permanent floor? Kind of what are your thoughts there?
Yeah, in general, the awesome thing to see with lithium-ion batteries is that there's a continuous and constant improvement that's happening. We have better electrolytes, anodes, cathodes within these systems, and each of those improvements gives you a little bit more that you can go further in terms of more energy you could pack into a smaller space. Fundamentally, I think lithium-ion does have a floor, and we will reach it somewhere around $50 to $60 a kilowatt hour. But there are a whole range of alternative chemistries and just evolutions on lithium-ion batteries, whether it's lithium sulfur, solid state, et cetera, that are going to come down the pipe soon afterwards. So expect to continue to see improvement over time.
Tal, what about the raw materials? I mean, people were predicting that there could be a shortage for the raw materials for batteries, even without the Russian invasion of Ukraine. Now everyone's shutting the door, slamming the door really on Russia, yet it's a major supplier of nickel, which is a critical component in batteries.
Yeah, so I think economics are a wonderful thing to watch. You look at everyone talked about peak oil back in the day. Everyone talked about peak silicon in the 70s. As economics work themselves out and people see a large enough market around lithium-ion batteries, mining companies will go and find supply. And we're already seeing massive investments now. Whether it's from the Glencores, Albemarle, and others now investing in new mines to broaden the supply chain needed for lithium-ion batteries. So I think for a couple of years here, we're going to have a little of a supply and demand constraint, and there's going to be some challenges around pricing. But long term, it's going to keep going down. We'll find those mines, the price will keep dropping.
How long do you expect the uncertainty with the war in the Ukraine to last? If you were to predict, I know you said you liked economics, so let's.
Yeah. We're at a very unique time right now in the battery industry where there is not enough tier one supply of batteries on the market. to supply all of the large automotive OEMs out there. And so we're going to see some very interesting deals being struck over the next year just to ensure that supply, long-term contracts, paying upfront, much closer to what you see in the semiconductor space, where people will pay fabs billions of dollars for their entire production run. You're going to start seeing that happen in the battery space as well, just to lock up that supply. But yeah, I think it will be a couple of years to really work out. I think in the meantime, you're going to see more deals companies moving to LFP. We saw it first with Tesla last year, where they started moving LFP batteries into their vehicles. Rivian just made an announcement similarly, looking at LFP batteries. And so people are going to start looking at what historically have been tier 2 suppliers in China for LFP batteries, as well as tier 1s like CATL.
Okay, so LFP, for those who were watching who don't know, lithium iron. Why the move to LFP?
Because it's available today. China basically was a couple steps ahead in the planning for the EV revolution. They were really trying to build up a domestic industry, and there's plenty of lithium iron batteries out there in China, and now it's the process of getting those qualified and built into EVs in the West here.
There's some LFP has some interesting characteristics too. I remember when Tesla first switched into their standard range to LFP, drivers can now always leave the charge all the way to 100%. They're not encouraged to only charge to 90. So obviously different battery chemistry and stuff allows for that, but it seems like especially Tesla has played up some advantages for what is a less expensive, maybe less energy dense battery.
Yeah, each battery is unique in its own right. The other challenge they had with LFP batteries is that it's really hard to tell where your gas gauge is with those vehicles as well. And so while they could charge them all the way up, they had a lot of customers in the winter in China when they first released them, having their vehicles not make it home after 100 mile, 150 mile range. And so it's really just a matter of really understanding these batteries to their core, no matter what those changes in which batteries you put in there. And that's the fun part in this space right now. It's just continuous. That evolution is continuing to change right now. And so we're going to be in work for a long time helping OEMs really understand these batteries.
Wait, I didn't follow that. So what do you mean the gas gauge doesn't work with lithium iron?
So if you look at a traditional nickel, cobalt, manganese battery, it's very easy. If you remember your Energizer battery, when you press the sides there, you'd see the light go up on the side to tell you what % full it is. That's just a voltage reading on the battery telling you what % full it is. So the traditional nickel, manganese, cobalt batteries that we have in most of our EVs, you have a very sharp curve there. And so it's really easy to tell where you are along the gas gauge from 100% full to 0% empty. The challenge with LFP is you have a very flat part of the curve in the middle there. And so even though you're reading the voltage, it's, you could be at 75%, you could be at 25%. It's really hard to tell unless you implement some additional methods to make your gas gauge more sophisticated.
And that can be done.
Can be done. You just have to fully qualify your batteries and understand them. And when OEMs sometimes rush their products to market, in that case Tesla, they didn't understand the challenge of understanding that gas gauge and calibrating it. And so they had some challenges. They've since corrected those, but it's really just making sure you understand those batteries before you put them in front of the end consumer.
Completely understanding that this answer might be both. What's the right solution right now in terms of battery sort of development manufacturing? Is it to go to that semiconductor, that processor mentality of buying out an entire fab's production run, or is it better just to build your own facility, or both?
I think however you can get a hold of the batteries today, we're seeing consumer demand for these vehicles rise exponentially, especially now with gas prices rising as well. So we have the challenge of increasing battery costs at the same time with higher gas prices. The economics around EVs are couldn't be more positive right now. So a lot of these OEMs now you're looking at really leaning in and trying to win market share as the consumer taste transitions to electrification. So however you can get the batteries, get them. That's going to be, paying for joint ventures in order to, get dedicated supply. It's, signing upfront payments for these EVs and figuring out how to finance that yourself. But really, however you can get a hold of these batteries so that you can grow your market share. The next couple of years are really going to make and break the industry here in terms of the groups who are going to build up that consumer confidence around these EVs and just excitement around the brands that emerge.
Is there anyone pulling a Tim Cook? I think Tim Cook sort of, at least urban legend wise, was part of the reason why Apple was able to secure so much manufacturing sort of early on. Have you identified anybody that's doing that particularly well now, or is there still open in space for somebody to come in and really, again, without maybe speaking to a specific manufacturer?
So I'd go specific on this one. You look at, historically, this has really been a 1-to-1 or 2-to-1 relationship with, Tesla, Panasonic, LG and GM, Panasonic and, Toyota. And so you've had these, pretty narrow relationships around supply. If you look at the consumer electronics space, most of these components are multi-sourced from different suppliers, so you can ensure you meet your demand. We're seeing that happen in the battery space. And, the first group that really did this in mass was Tesla. When they started, they first brought on LG. They work with Samsung now. They sort of did it because at this stage, they needed that battery supply to launch all their vehicles, the batteries on the grid. And they're still, supply constrained on the battery front. And so they were the first to really do that. And we're seeing the rest of the industry start to broaden their supply chain as well.
So Tal, following up on that, are automakers going to be able to bring this in-house at some point? Because when things get to a certain volume, they have a make-buy decision, as you know. And if the volume's good enough, they want to make it themselves. But what's your sense? Are they going to be able to do that? Or will they always have to rely on these battery companies?
So I'm going to caveat this up front. We have a number of automotive OEM customers who are trying to make their own battery factories themselves now. They're looking at both current generation as well as next generation solid state batteries. Our job at Voltaiq as an analytics company is to help them move as quickly as they can to produce those new batteries. That said, it's incredibly hard to make high performance battery cell today. Even if you look at Panasonic, it took them about 5 years to get the Gigafactory from even when the ground was built and the facility was there to get up to full yield, which they announced, I think it was 2020. 5 years to get that up and running and get to high yield that they were looking for. And so they have that expertise in-house. It's really going to be a challenge for anyone else to even meet those timelines. And so, with analytics, you could probably get there sooner, and we're helping our customers get there, but it's going to be a challenge for sure.
One of the biggest, I don't live in the Smile States. So my friends and neighbors have a different opinion on EVs than, let's say, folks do in San Francisco or whatever. The biggest critical sort of like pushback when I talk about what I do is battery recycling. What happens when the batteries are dead? What changes are happening now? What do you see happening in the future? And how do automakers plan for what's about to be a whole lot of not automotive usable batteries?
So yeah, I think, you look at lead acid in the batteries, 99% of them are recycled. I think a similar supply chain is going to build up around batteries, really closing the loop around that life cycle. At the end of the day, there's two options here for those batteries. First, I think actually even before that is if you have a good understanding of what the residual value or resale value of that vehicle and battery pack specifically is, you can continue to resell that vehicle to additional consumers over time. There's a lot of people here that drive, 15-year-old cars on the road. Similarly, most people don't drive 200, 300 miles a day. They're just going on shorter commutes. So go give it to your kid when they're driving to school. And so just the key here is understanding what the remaining life on those batteries is, and that'll enable the extension of their first life. From there, those batteries have a few different paths to go down. I think it's always going to be challenging to put batteries into a second use because they're really designed in a custom way for that first use application. But in order to do that, again, you have to really understand how good those batteries are. If you take a bunch of those batteries, put them on the electric grid, even if one of those is bad, all of a sudden you have to send a whole team out there to go replace that battery, and it becomes a big logistical nightmare. And the economics start making less and less sense. And so a lot of our advisors, you look at Selena Michalowczak now at QuantumScape, used to be at Panasonic, signed some deals with Redwood Materials. As soon as you build up that recycling capability, you can get a lot of that residual value out of the battery pack through the extraction of the raw materials that are going to be needed for production as well. And so I think there's, given how big these battery packs are, they're not going to just mistakenly go into your trash like your cell phone battery. And so I think that recycling chain is going to end up building up, and it's going to provide a lot of value back in as these materials get remanufactured into new batteries.
Tal, I'd like to get your input too on battery swapping. As you know, this is really being pushed by some automakers in China. NIO, the EV startup that's getting all kinds of accolades, is probably leading the charge in China on that. What are your thoughts on battery swapping, where instead of sitting around for 20 minutes, 30 minutes to get it recharged, you swap it out in a couple of minutes?
So yeah, in general, it's an awesome concept. It does add engineering costs to the system. And so I think at the end of the day, for consumer applications, if you can go get 150-mile range in 5 to 10 minutes charging, that may be good enough for most consumer applications. That said, I think there will be specific applications where swapping makes sense. I think the scooter use case with Gogoro is an awesome one. Very similarly, I think fleet applications where you have a large depot and you can go and swap lots of batteries. Maybe shared mobility. If you look at an Uber with lots of drivers moving in a certain region, similarly you could see that. So very similar use cases in my mind to hydrogen economy, where if you have large depots and large fleet operations for heavy transportation, it may make sense to implement that added infrastructure and cost that comes with swapping batteries.
So along those lines, what are your thoughts of designing what they call cell to pack, where instead of putting the battery cells in a module and a module in a pack that goes into the car, you just go right to the pack?
Yeah, so I think fundamentally with all these things, it's about designing safety into the battery pack itself. And you could do that at the cell level by beefing up the mechanical strength of that individual cell, or it could be on the larger pack itself. And so as long as the organization is taking the efforts to understand the mechanical stresses that are going to be given on these battery systems, they could then design around that, whether it's a cell to pack or individual cells.
And so if you do a cell to pack design, does that prevent you from doing battery swapping?
If you make the entire pack swappable, it should work as well. So okay. We're great at designing different systems and components, and I think just figuring out exactly how we want to build the edges of the system and where it could be swapped. I know there's a lot of belief in the industry that we should have the ability to go and replace individual batteries within these packs as well. Again, that's going to be very difficult if you design rigidity and all that structural components into that cell to pack design. And so it's going to be a trade-off. How confident are you in how long your battery is going to last versus the benefits of having it all designed into a single unit there.
Mm-hmm.
Do you see one being particularly favored in the near term? I know that because on the consumer end, I see, some automakers touting, oh, well, we have a completely flat floor because we've got this whole battery pack, while others are saying, well, we're able to sort of adjust to fit this structure or this thing that we're going for now. I guess a larger question is an overall sled design going to win out, or are we going to see some creativity in terms of like what we see today?
I think you have a lot of flexibility at the end of the day with batteries. You look at, just look at Tesla versus GM. We have large, prismatic batteries versus cylindrical batteries, and they both get to very similar places. VW and, you could use pouch, you could use prismatic, you could use cylindrical, and you can get to a very similar place. It is often cheaper to manufacture the pouches or prismatic cells, but then once you design it into a system, you end up at a very similar place in terms of range, energy density, price, and so you have a lot of different pathways that you could take and be pretty creative in terms of what batteries you incorporate into your systems and how you do that.
So what about the future? What about all these breakthroughs we keep hearing about, Tal? What are your thoughts on things like solid state batteries and when we might see them in volume production? And that's the key, volume production. Or, this talk about lithium sulfur batteries with graphene and the like. Are there any breakthroughs out there that you think, that's what we got to keep an eye on?
So I think just given the rising demand and continued, need for range in the existing EVs, there's eVTOL applications with flying taxis and whatnot. We're going to continue to push the envelope in terms of new and better batteries. I think there's two pathways here. Just in the near term, the reality is that we're going to be moving forward with the traditional lithium-ion battery. We're going to see improvements with silicon and other components in there. At the end of the day, to qualify a battery for a vehicle, it's about a 5-year program. And so even if we have one of these new chemistries and new systems developed, it's going to take a while to actually get that into our end consumer devices. And you'll see these stepping stones where companies actually start with something geared towards consumers. One of our customers, Sila Nanotechnologies, they have their batteries in the Whoop fitness tracker to start, and then they're moving towards EVs. They have deals with BMW and Mercedes. And so you'll see this evolution here over the next, at least 5 years. It's really traditional lithium ion with some enhancements that we'll be seeing. But again, helping our customers try to accelerate that next generation product so they can get in EVs as soon as we can.
Yikes, 5 years to qualify a battery? Why does it take so long?
It's because batteries are complicated. They're unlike any other component in our modern devices.
And explain what you mean when you say qualify the battery.
Yeah, and so it really comes down to the fact that batteries are much like living beings. They're very sensitive to temperature, their environment, exactly how they're driven, what profiles. And in order to really simulate that electrochemistry that's happening in the battery, you have to operate them very similar to how you're going to use them in the real world. So just like you would, simulate that 10-year lifetime for the vehicle with someone driving every day, you're going to have to do that in a lab. And the fastest way you can accelerate that, you can maybe, someone's driving 2 hours a day, so you can maybe do 12 cycles in a day-long period. But the challenge here is, that battery's on a charger for 6 to 8 hours. So we're looking at a real-world use case where you can maybe do 2 cycles in a day. So you're looking at 2.5 to 5 years just to qualify and test that battery to see if you're going to get that 10-year warranty. As we've seen in the industry, if you don't go and do that qualification, the implications of these larger, whether it's recalls or warranty returns, could be pretty dramatic. This is the most expensive single component in those vehicles. And so it's not something you really want to rush unless you really understand those batteries.
Can a lot of that development be done electronically? Simulated, or does it have to be real world?
So yeah, I'm an experimentalist, and so I like to test everything. But it's really the simulation and testing is peanut butter and jelly in the space here. Really bringing them together. So it is a combination of testing. You could probably minimize some of that testing if you understand the failure mechanisms in those batteries, and then combine that with simulation and digital twins. But at the end of the day, you still need to test these batteries. It's still going to be at least 2.5 years before you get them into your EVs.
Sure.
Isn't part of the problem, I think you told me this before when we had met, that if you run into a problem, you got to go back to go and start all over again. You can't just pick it up from where you had the problem.
That's the challenge with batteries is you don't know if you have a good battery or bad battery most of the time until, months or sometimes years down the road. And that's where, batteries, they fail. They look like they're doing well, all of a sudden fall off a cliff catastrophically. And the challenge is if you're in that 2.5-year qualification process and you have one of those failures, all of a sudden you're back to square one and you have to restart the clock on that next battery that you're qualifying. And so it could be multiple months or years in program delays for getting these new EVs launched. And so the key here is really broadening your supply chain so you have multiple suppliers ready to go when you're launching each of these EVs.
Hey, we're down to the end here, about a minute or so, but real quick question. People that out in the street, the impression is your battery in your electric car is going to go out and then you're going to face a whopping big replacement cost. How long do you think these batteries are going to last in most of these electric cars?
So the reality what we're seeing with some of the early EVs, they're lasting more than 10 years beyond the warranties that were put out there. And so, the key is monitoring and knowing which ones are going to fail sooner and replacing and dealing with those. I know my prediction is most of these EVs we'll see on the road for 15 years or longer.
Real good. With that, we're going to have to wrap it up. Tal Sholklapper from Voltaiq, great to have you on the show. Chad Kirchner from EV Pulse, great to have you on as well.
Thanks for having me.
And for everybody else that's watching out there, I hope you learned a lot. I certainly did. And I want to thank you all for having tuned in.
Thanks, guys.
Autoline This Week partnered with the Consulate General of Canada in Detroit to produce this episode.